Hello, we're going to continue our conversations about solving equations. Recently we've been working with a zero product property where we were able to factor an expression if it was set equal to 0 and then know that one of the two factors had to be equal to 0 since the product was equal to 0. But there are situations when we cannot factor and we need to be able to address those in our mathematics. Some of the vocabulary we're going to use is factor by grouping, completing the squares, zero product properties, zeros, and factors. One thing I'd like to add is a review topic of the quadratic formula. And for those of you who know all those types of songs that you can find on YouTube, your friends would greatly appreciate it if you could sing them to them, as it definitely helps you remember exactly what they are. But it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So you might want to highlight this was something that you learned last year for sure. Lots of videos. It's definitely a tool worth remembering long term, such as pre-calculus or even calculus. So we get to our problem and we say find all real numbers or all real solutions to the equations. And then we see it's already factored for us. And so if we were using the zero product property, we would set each one equal to 0. X squared minus 6x plus 3 equals 0. 2x squared minus 4x minus 7 equals 0. And then I try to go even further and find even more factors. And what I see is x squared minus 6x plus 3. I can't think of any numbers that multiply to 3 but add to negative 6. On the other expression, I have 2x squared minus 4x minus 7. I can't think of anything that multiplies to negative 14 that adds to negative 4. So I kind of feel stuck at the moment. And so we'll write that down. I notice we cannot factor either expression. And if we can't factor either expression, if we can't create that multiplication problem from either expression, we're really unable to be able to use the zero product property, and so you might feel kind of stuck. So one tool that you learned a while ago was the quadratic formula. So you might want to start this. This is quadratic formula. And to even be able to begin proving the quadratic formula, you've had to know this concept called completing the square. Okay? Since you probably saw extensive work with the quadratic formula a year ago, I'm going to focus most of this video on completing the square. And then we'll come back and we'll check one of the solutions with the quadratic formula just to double check our work. So what is completing the square? Completing the square is sort of a set of steps that allows us to create a solvable equation. Okay? So essentially when I'm looking at this, I have x squared minus 6x plus 3 equals 0. And the first step that I am required for completing the square, I'm going to abbreviate this CTS. Number one step is we must make sure our a equals 1. Make sure a equals 1. Okay, so as I'm looking at this example, a does equal 1 as we think about standard form. So a is referencing ax squared plus bx plus c. So this is standard form. Standard form. And I do see this invisible 1 right here, so we're good. But if I look at my other example, which is 2x squared minus 4x minus 7 equals 0, I'll notice that it does not equal 1 at the moment. It equals 2. And so if it does, we have to divide each term by a. So if not, divide each term by the a value. So I would take and divide each term by 2, leaving me with x squared minus 2x minus 7 halves equals 0. And I understand you might be uncomfortable with the 7 halves for the moment, but we'll just work through the process. The teacher's going through it, so it gives you a lot of time to think. You can pause the video at any moment. And so now we have a leading coefficient of 1. Our next step is we have to get rid of the constant. So using inverse operations, we really want to be able to move the constant to the other side of the equal sign. So ultimately I want ax squared plus bx by itself on one side of equal sign. And so for this scenario, I'm going to subtract 3, and I'm going to get x squared minus 6x equals negative 3. On the other problem, I'll have positive 7 halves, and so I get x squared minus 2x equals positive 7 halves. Step 3 is probably the most critical, but I have to take half of the b term, the middle term, the x term, and square it. So symbolically, it's going to look like this. B divided by 2 squared. Add to both sides of equal sign. So on my left-hand problem, I have x squared minus 6x. So 6x is my b term, so I'm going to take half of 6. Half of 6 is 3. 3 squared is 9, so this next step is going to look like this. X squared minus 6x plus 9. Negative 3 plus 9. So what you'll notice is I kept it balanced because I added the same number to the right and left-hand side of the equation. And what this does is it sets me up to factor a perfect square. So now I get to factor into a perfect square. And what this looks like symbolically is x squared plus bx plus b divided by 2 squared equals x plus b divided by 2 quantity squared. And so I can take this now and I could say that this was x minus 3 quantity squared. I can simplify the right-hand side. Negative 3 plus 9 is 6. Now I have this perfect square. So number 5, take the square root of both sides. When I do that, the square root and the square are inverse operations. So what I'm left with is x minus 3 equals the square root of 6. 6. Do not forget the plus minus. So I have to go back and double check to make sure I did this mathematically correctly. And I'm going to add a plus minus if I've forgotten it. And step 7. Solve for x. And so I see the x is here, I see a 3, so I'm going to add 3 to both sides. And so my solution is x equals 3 plus or minus the square root of 6. And that's essentially the process of completing the square. If you go back to the previous problem, okay, we'll continue this one off. It looks like I have gotten the ax squared plus bx on one side. So now I need to take half of the middle term. So half of negative 2 is 1. 1 squared, or is negative 1, but 1 squared is 1. So I'll get x squared minus 2x plus 1. 7 halves plus 1. So again, I've kept my balance because I've got it on both sides of the equal sign. And so now I can perfect square this. X minus 1, quantity squared equals 9 halves. A little side work would help you. 1 is the same as 2 over 2. Add the numerators, keep the denominator. Take the square root of both sides, x minus 1, square root of 9 halves. Don't forget the plus minus. And then x equals 1 plus or minus the square root of 9 halves. Now our answer isn't complete because we've got an irrational number in the denominator, but we've completed at least the steps, and now we can make some good math choices and make sure that this is where it needs to be by rationalizing the denominator. So what I see here is x equals 1 plus or minus 3 square root of 2 all over 2. And our final answer, if I wanted to get it all on one denominator, there it is. So again, this completes all the steps. This is the best final answer. And you can check it with a quadratic formula. So take a moment, make sure you've got your steps written down. Think about the two examples that were given. One had a leading coefficient of 1, one did not. One is obviously a little bit more complicated. But definitely make sure you can complete the steps. If you have any questions, write them down. Come in tomorrow prepared to ask those questions during class. Thank you.